So thanks, Jessica. Thanks, John. I know how much work goes into organizing one of these things, and you've kind of given me the unenviable position of following a whole day of really cool presentations from a bunch of students and being the last thing standing between you guys and refreshments and other things. So I will try to stick to time here. What I'm going to do is give you an overview of what we call the open standards for the practice of conservation and Miradi software. It is the foundation, we hope, of an applied evidence-based science of conservation. I want to back up just a little bit, though, and I want to start with a story. And this is a story that I stole from my friend Bill Sutherland. It took a Brit to kind of have this story. So how many of you know that George Washington, the founder of our country, was murdered? They don't teach you this in the history books, but here's the story. So in December 1799, George went out and looked at his plantation. And on the 13th, he had a sore throat. On the 14th, he had some breathing difficulties. And then his overseer came and gave him some vinegar and molasses. They took out almost a pint of blood. His personal doc came. He put some dried beetles on George's throat. They took out another pint of blood. There was no improvement, so they took out another pint of blood. They gargled poor George with some vinegar and water, and he nearly suffocated, apparently. They took out 2 more pints of blood. And then the prominent doctor came. Dun, dun, dun. So what did he do? You guessed it. He took out another 2 pints of blood. George had a low pulse. And George died. Okay? So they took out almost 7 pints of blood from the dude. So he was murdered. Who and what killed him? Well, it wasn't until this guy came around a little bit later and came up with the idea of numerical methods to examine the effectiveness of medical interventions. And when he did that, he showed that bloodletting in most situations is not really the treatment of choice. So the reason Bill and I tell that story is that if you look, and this is also from Bill Sutherland, how do practitioners make decisions today? I go around the world working with conservation projects, and when you find somebody, you're doing an education of school kids campaign. You're doing something to put some fire on the landscape. Why are you doing that? And the sad thing is, it's often, if we look at the spectrum from myth to anecdote to observation to comparison to randomized replicated controls, it's very often that we're making decisions on what to do based on myth and anecdote rather than documented evidence of what works and what doesn't work. Where we want to be in the future, my wife works for the National Institute of Health. She works for the Human Genome Project. She does real science. They're in that realm of randomized replicated controls. We may not always get there, but we want to get to a place where we're working and taking action based on evidence that actually works. We don't want to be medicine 200 years ago. We want to speed it up and do evidence-based conservation. So that leads me to the open standards and what I call the foundation of an applied evidence-based science of conservation. So as Jessica said, I work for Foundations of Success. We are a not-for-profit organization. We've been around about 12 years. And our mission is to improve how conservation gets done. We don't actually implement conservation projects. We try to make other people's projects better. So we help people of all shapes and sizes design, manage, monitor, and learn from what they do. We're also part of something much bigger called the Conservation Measures Partnership, or CMP. It started off as a half-day meeting at the Society for Conservation Biology in 2002 of members of a bunch of the orgs that you see here. We got together to chat about adaptive management and learning and all these things that we had in common. And we found we had so much to talk about, we turned it into a regular thing. So the CMP now meets a couple times a year. We have phone calls, and we do work together. We've now added a bunch of different NGOs from around the world. In recent years, we've started to pull in the major foundations that are involved in environmental work, at least in the US and abroad, or some of them. And in recent times, most exciting, we've actually started to add the relevant federal and government agencies. So US Fish and Wildlife Service has joined, USAID has joined. Some of these other organizations that you see here, they're maybe not formal members, but they're part of the partnership in using these materials. And it's not just the US, it's also the rest of the world. The Canadians, the Swedes, every national park in Madagascar is now managed with the systems I'm talking about. Same for Mongolia, same for other countries as well. So we're really talking about a global movement here. Finally, I'm here representing something called Miradi. Miradi is the Swahili word for project or goal, and it's a set of software tools that I'll introduce to you as well. So in this presentation, I hope to do 4 things. Talk about the open standards and give you a quick intro. Give you some examples of what it is, especially scaling up from projects to programs. Talk about how we support adaptive management, some of the tools that are out there. And then that's my normal talk, but given the talks and what we heard about today, I thought I'd throw in a fourth bit, which is reflections on creating applied interdisciplinary conservation science. So I'd like to talk a little bit about that as well. So let's start with that first part. We're interested in projects. Projects is one of those words that means a lot of different things, but for us, it's a group of people trying to do something to change the world. It could be my neighbors working on restoring the river, the gorge, the Potomac Gorge where I live, and going out and pulling weeds and doing stuff. It could be a plan for a state or a national park. It could be a species plan across its entire range. It could be looking at impact evaluation of sustainable soy production globally, or it could be a state wildlife action plan for something as big as Idaho. So for us, projects are all shapes and sizes. Projects, as most of you probably know, in conservation and resource management, face some real challenges. We take place in real complex and dynamic systems. We have to deal with ongoing and unpredictable change. We're dealing with rapidly changing competitors. And our teams don't have full information, must take immediate action in the face of uncertainty, need to report our performance to our funders and our supporters, and we can improve and learn. So people have come up with this term adaptive management. A bunch of you all were using it. And it's a term that people throw up to solve some of those problems. So some people think of adaptive management as whatever you want. Hey, I tried something and it didn't work, so I'm going to tell my boss I'm managing adaptively. No, we don't really want that. So the real roots of it go back to a guy named Buzz Holling and a bunch of his colleagues in the 70s and 80s. And they were academic ecologists, and they were looking for ecological resilience in systems. They had this idea that you might want to treat your policies as experimentation, that you need models to understand the system and the experiment that's going on. And they talked about passive versus active experimentation, different forms of experiments. So it's pretty cool and pretty revolutionary stuff. Much as the respect I have for Buzz and company, one of the challenges they had, though, was maybe communicating it a little bit. So they had a chapter recently from 79 called Lessons for Ecological Policy Design. So they knew they had to take their findings and compress and simplify them so that managers could use them in the transfer process. But in that same exact chapter, you get a bunch of equations that look like this. And I love the line here. The interpret equation 9 is both simple and important, so keep that in mind. And then they had a bunch of diagrams that look like this. So if you're trying to manage spruce budworm and you're trying to talk to the forest manager, you go to your boss and say, yeah, I think we're here on the graph. I think we need to move over here. What do you think? Not so much, right? So I think these guys were on the right track, but I'm not sure it was always accessible in the policy and action environment. So a few years back, those of us at the partnership, we decided, well, we're not the only people in conservation who are worried about these issues. There's a lot of other smart people around the world who all care about these same ideas. Let's learn from them. So we went and looked at 35 studies in the business world, and 42 in education, and 55 in international development. This next slide is a little scary for late in the afternoon, but bear with me. This is the history of performance measures in the business world over the last 500 years, all in one slide. So it goes back to the 1500s and the invention of double-entry bookkeeping. And you can see each of these blue boxes is a different system we studied. Activity-based costing, Six Sigma, balanced scorecard, benchmarking, et cetera, et cetera. I could show you a similar slide for development, a similar slide for education. I'll spare you all the gory details. Here's what we learned. First, there's been a migration in every one of these fields from doing a big formal evaluation at the end of a project or program to, in the 80s and 90s, doing more participatory or formative evaluations. And in the last 10 years, every one of those fields has gone to project cycle-based monitoring. So you put your performance measures in the context of the work you're doing. We also learned that there's very different questions that require different answers. So in our world, there's the status question, which asks, how are species and ecosystems doing? So how is that salmon population doing? Or how is that habitat doing, that riverine habitat? That's an important question. But it's a very different question from the effectiveness question, which says, if we're dumping a bunch of woody debris in a stream because we think it's going to lead to better salmon habitat, is that a good thing to do? Or is that more like the bloodletting that killed poor George? And here's the truth. We do a lot of stuff like throwing wood in streams. We don't know whether it's working or not, or how to make it better. And given the magnitude of the problem we're facing, that's unacceptable. So we need different systems to look at those different questions. And then the last part of this is we all confuse the heck out of each other with words. If any of you have an NGO background or you've been in offices, you might have been in the debate. What's bigger, a goal or an objective? How does that tie to an outcome? And how does that relate to an output? Okay? It doesn't really matter what you call things, but it does help if people working collaboratively on stuff have a common way to talk about their problems and issues. So that led us to create the open standards for the practice of conservation. We're actually up to version 3.0. The word open comes from the IT world, open source. No one owns them. Anyone can take them and use them and do what they want. And these are the open standards. Every time I put this diagram up, I always make sure to point out there's nothing new in here. There's nothing that Deming didn't invent 50 years ago with plan, check, do, act. In fact, there's nothing here that the Greeks didn't invent 2,000 years ago when they came up with the scientific method. So this is not new. This is project cycle management that all our agencies and organizations and work have been doing for a long time. But what is interesting and novel about it is it's a set of tools to go through this process in a common way that hopefully makes some sense for conservation. And I'd like to show you what those are. So I'm going to give you a very simple project example to start, and then we'll look at some more detailed and complex parts of it. So the first step says, what are you working on? What's the problem that you're trying to face? Because you need to bound the issues and things that you're looking at. So in this case, we might be helping this community manage their marine resources, and that's the project that we're looking at. It also matters who's having the conversation. We'll come back to them more later. But who's on the project team is a really important question in terms of doing good adaptive management and thinking about what happens. We like to start with a small team and work our way out to the other stakeholders and advisors. So Holling talked a lot about models, but he had all those mathematical equations. We like models too, but we're a little bit more simplistic. So for us, a model is what Peter Senge would call a mental model, getting a group of people on the same page about what's going on. What do you care about? Well, we care about turtles. And what are some of the problems? Well, those turtles are becoming someone's dinner. Maybe we care about fish and they're being commercially harvested. But maybe those fish are also a really important protein resource for that local community. So what's that picture of what's going on in that world? We then want to figure out what we're going to do about that world and plan our actions and our monitoring. So you get a lot of strategic plans that I've seen around that are big documents with the word strategic plan on the cover. It ain't strategic. What makes a plan strategic, as my old boss would say, is when it says not just what you are going to do, but also what you're not going to do and why. How do you make choices about how to spend your limited time and treasure? So the open standards help us figure out which targets require the most attention, which threats are most critical, and how do we spend our limited time and treasure to change the situation. The next step is then to treat your actions as hypotheses, just the way Holling talked about it. So in this case, maybe this community, they had an idea. Let's revive an old traditional way of managing marine resources by setting up seasonal closures or temporary closures to marine resource harvesting. If you say that, there is an assumption or a hypothesis behind that action that you can actually diagram out what the theory of change might be. And so your trick is to lay that out and then to collect the data to implement the action, but also to collect just enough monitoring data so that you can test that. So in this case, we're going to count clams before and after we set up the no-take zone. You got to take those data and analyze and make sense of them. So the blue here were the numbers and sizes of clams before they started. The orange is what happened after. You can see in this case, the action actually worked. Hooray. But if your action doesn't work, well, don't keep doing the same thing over and over again, right? You might want to think about why didn't it work? What can we do? How do we adapt and make it better? And then the last part of these open standards are to capture and share your learning. You need to share your information with your project team, but there's also lots of other people doing something similar who might benefit from learning what you were up to, so you want to share it more widely. So if you ask me what is adaptive management, I would say it's doing that iteratively. It's going through that process in an iterative fashion to learn and improve about your work. Or to be really clear, it's that or some equivalent. That's the one they use in the Chesapeake Bay. That's what U.S. Fish and Wildlife Service is currently using. This is what USAID is using. It doesn't really matter what flavor of this cycle you use, but it is important to have a common language and be going through that process. So that's a brief introduction to open standards and what they are. Let me give you a little bit more real-world, different examples of how this all works. So we need to take this to scale. This methodology was initially developed by the Nature Conservancy and others over 25 years, and we started with very small projects, but now we want to kind of do this at much bigger scales. Why? Because conservation requires large ecosystems, we're managing species across boundaries, there's many stakeholders, and again, we have to show our return on investment, compete with other funding priorities, and improve and learn. So I want to give you 4 models for going up to scale. The first, Model A, is about scaling up project size. So instead of having a bunch of small projects, we might have bigger projects in area. So for example, a few years ago, we started working with the Helmsley Charitable Trust. I don't know if you know Leona Helmsley. She was the Taxes Are for Little People person. But she was very wealthy. She owned the Empire State Building. And when she died, she left all her money to her dog. Fortunately, the dog died, and the dog had a conservation bent, so they left all their money to a conservation foundation. It's now the 3rd or 4th largest conservation foundation in the US. So they were interested in the Galapagos, and we used these open standards to help them figure out how could they make funding investments in the Galapagos. So this is an example of a very big project. Our task was to come up with a strategic plan for their investments over the next 5 years. And it starts, again, one of the first questions is, what is the project scope? So we asked them, well, are you interested in one village? Are you interested in Isabella Island? Are you interested in all the islands? Are you interested in the archipelago? Or are you interested in all of Ecuador? Here's the thing about the open standards. There's no right answer to that question. But the open standards do demand that you answer that question. Because if you're trying to manage all that, that's a very different question than if you're just trying to manage that. So you have to be clear about what you're going after. Each choice leads to a valid program, but they're all very different. It also asks, again, what are your focal conservation targets? What do you care about? So we might care about terrestrial animals, we might care about marine animals, and we start to represent conceptually what those things are. At this scale, you'll notice we're being a little bit more vague about what our targets are, but we're at least being clear that we're interested in both terrestrial habitats and species and marine. You could do this, or just this. They'd take you different places, but you have to, again, choose. Another choice is what are the threats and what are the priority ones? So again, going through that process, we create a model of what we care about and what are some of the problems. Illegal and unsustainable fishing, urban infrastructure and development, invasive species. So again, we're, as a group, saying, what are the things that we care about? And by putting it down on a screen or on a piece of paper, we can then take that to stakeholders and have them help us vet what they think is important as well. So it gets a little more complex. You can see a whole list of these threats. And these little lights here show that we're actually prioritizing which of these are most important based on a certain set of algorithms. And then we think about, well, what are we going to do to change that situation? Well, we could do some work to present new invasives. We could do some work to eradicate existing invasives. Again, we're thinking through what are our options. So that's one example at a very high level of doing this at a large scale. Similar examples would be doing a plan for the reddish egret across its range. So here again, our choice of targets is at fairly large scales. We're caring about the egret populations, their breeding habitat, and their foraging habitat. And we can think about those targets, and again, we can think about threats and rating the different threats to those different targets. Again, prioritizing what to do and where to work. There's one last example at a large scale. This is a non-place-based example, but World Wildlife Fund is interested in transforming markets. So they have this conceptual model. This doesn't look like the other conceptual models, but I assure you it is. Jason Clay, the markets leader of the program, has a story about how in the world there's 8 billion consumers. There are 1 billion producers, people who mine, farm, and otherwise harvest commodities. And there's about 300 companies, 200 companies that connect them. So where's the leverage point in that system? What would you go after? So in this case, this is Jason's example, but to me it's actually a conceptual model of what the situation is. That's what they care about, that's the threat, and then this is the chain of factors that are leading up to the potential intervention that they're going to be doing. So we're looking at a conceptual model in this case. So they're looking at, again, prioritizing through a set of criteria, which are the most important commodities we can go after, which are the most important companies in each of those commodities. And then we create a results chain. So a results chain is another open standards tool that lays out your theory of change about how you think your action is going to lead to the desired outputs. In this case, we want to get to threats from commodity production being reduced. Our activities here are to identify companies and develop standards. So we have a bunch of intermediate results, a leverage point established, credible standards in place. Key companies are then aware of standards, they set internal policies, and they actually implement the standards. And we can do some additional work with industry and with financial institutions. If we do that, and notice this is an if-then statement, then companies will act and put pressure on their upwards and downward supply chains. If we do that, then commodity production will meet the standards, and if we do that, those threats will be reduced. So we're laying out that logic about how we think our actions are going to lead to the desired outcomes that we're hoping to have. That's a hypothesis, right? There's a time element here. So you can see that this is 2009, and that's all the way up until 2020. So one of the things is it helps us avoid short-termism. If I have to get a grant from someone, and it's only a 2-year grant, and they want me to report on performance on this work, all the funders want to see, well, did you reduce threats? Did you save biodiversity? I got to go back to them and say, I ain't going to show you for 2 years any change down there, but I will be able to show you, hey, we found that leverage point. Hey, we have a few key companies aware. We can build up our progress over time. So it lets us set very measurable objectives that we can track based on these results, things like this. And then based on those objectives, we can also come up with specific effectiveness indicators that show our progress towards getting towards work over time. So it's really important to lay out what that theory of change is, what you're trying to accomplish, and where the gaps are, and how long it will take. So that's one model. That's about big projects or big programs. Another way of taking this stuff to scale is what we call replicating sites in programs. So the idea is you have a couple red and a couple orange places. We want to have a lot more of them. So if that's a project, a group of people trying to do something to change the world, we can define a program as a group of people who are implementing a whole bunch of projects that collectively add up to something to change the world. So a program is both a large-scale project in its own right, but it's a collection of a bunch of related things. So I just spent the last 14 days in Idaho, touring around Idaho, helping the state of Idaho develop their state wildlife action plan. And the way they're doing that is they've divided Idaho up into 14 ecological sections. So they are using Bailey's ecoregions and then ecological sections as sort of their management unit. Idaho, it's a kind of a Goldilocks problem, right? If you want to develop a conservation plan for all of Idaho, it's just too damn big and it's too varied. If you want to develop a plan for this site and this site and this site and this site and this site, it's too much. So we're trying to find that Goldilocks sort of size for the program. We hit on these ecological sections. And basically, through a whole stakeholder process that I won't go into now, say, for example, for the Oahe Uplands, we're developing one of these open standards conceptual models about what is it that we care about in the Oahe Uplands, what are the threats, what are the drivers, what are the strategies, all that kind of stuff. And we've developed that not just for one of these sections, but now for all 14 of these sections. What that lets us do is to start to roll up performance measures from projects to program level. So if this is project A and project B and project C and they're adding up to program 1, maybe our goal is to have a bunch of wetland restored. And what we want to get to is a state of the world where project A is responsible for 120 hectares and B for 165 and C for 140. We can measure their performance over time, but we can then add it up to measure the program's performance over time. And as a bonus for management purposes, if you're the manager and you kind of review these results, you can go to project A and say, yeah, you guys are doing pretty well. Project B, hey, great job, you're really doing cool. What can we learn from you? Things are going really well. Hey, project C, what up? Do you need some additional resources? Do you need some learning? What's going wrong? Can we learn from that as well? But it's a way to sort of track what's going on in that overall system. In order to do these kinds of roll-ups, there is one sort of minor, well, a bunch of problems, but one of the biggest challenges is this one. If one of the projects or ecoregions is talking about breeding pairs of mountain lion per kilometer squared, and the other is calling about adults of puma per mile squared, even though it's the identical measurement in the same animal, you'll never be able to roll that stuff up. So there's a lot of standardization that has to happen in order to be able to do this kind of thinking and make things work at a program level. All right, beyond program level, I want to talk about cross-project learning. So this is the third model for how we go to scale. And this is the idea, if we have work going on in a couple of these places, can we take what they've done and use it to influence other related efforts? Maybe not by our organization, but by other people around the area. And then take over the world. So a few years back, we were working with something called AFWA, the Association of Fish and Wildlife Agencies, which is the association of all the state wildlife agencies across the US. And there's something called state wildlife grants. So Congress basically appropriated a bunch of money for states to keep common species common and to fund work by 56 states and territories. But the problem was we had to justify to the powers that be in Washington in a bad budget environment that this stuff was actually working. So we went to the OMB examiner, and the dude was sitting there, Office of Management Budget, for those of you not from the Washington area. These are the people who kind of govern how all spending gets done in the federal government. We went to the examiner, the dude was sitting there in his black sunglasses and black shirt and kind of looking all spooky. And we asked him, so on a scale of 1 to 10, how important is that we have a means of evaluating the effectiveness of projects funded with the state wildlife grants? And the guy looked at us and goes, 15. So this is the currency. So what we did is we formed a working group with a whole bunch of folks, including Mike Harris from Georgia, who some of you may know. And in that working group, we basically said, okay, these state wildlife grants, really what they are now is a bunch of random acts of conservation. So we might be in Kentucky, and we might have a bat population, and we're going to put up a gate, and we can get some money to gate some caves and mines. Why? What's the theory of change there? Well, we want to reduce disturbance by humans and disturbance by feral cats. Those are the threats we think are there. And we think that's related to human access and access. So we can actually, as I showed you before, come up with a bunch of indicators that we could track to look at the performance of this grant. Well, that's nice. But there's thousands of these, right? How do we make sense of this? How do we roll these up? So let's go to a totally different system. Let's go to the beaches of New England. And now we're looking at piping plover, and we're looking at a different species, a different landscape, a different region, different threats. In this case, it's dune buggies and dogs and foxes that are coming eating the little nestlings. Everything's different, right? But guess what? Everything's the same. It's really the same underlying theory of change about protecting nesting sites. And so we can actually create what we call a generic results chain about a predator exclosure strategy and see what that would look like. And we can actually come up with generic indicators and objectives as well. So that could lead us in the future to come up with a report that might look something like this, where we funded 37 of these things, and here's how much they average, and here's how much work. So at least it's a little bit more lumping, so we're not going to Congress with a whole bunch of random things, but we're being a little bit more systematic about what that might look like. But more importantly, so what we did is we took 11 of the most common state-funded wild conservation actions, and you can see the list here. So I'll show you one for species restoration. And what we did for each of those is we came up with a definition of the action, some examples of what actually happens in the real world, a generic results chain, so it's that theory of change in a little bit more detail. And then from that, we were able to create the results, standard objectives, standard measures, both at the level of an individual grant, but then as a roll-up level. And from all that thinking, we could create a bunch of monitoring questions that people could answer when they're applying for money. What worked in your project and what didn't. So the cool thing is once you have those questions, if someone's applying for money, then you could put that in their part of the regular business process of applying for and reporting on their funds. You could ask them a bunch of these questions, and you could get the data to actually roll up and show up what's working and what's not working. And so all this is supposedly being baked into their wildlife tracks database, which the Fish and Wildlife Service is now releasing. At some point, I'll tell you after a couple of beers some of the challenges of actually getting it implemented, but that's a whole other game. But in theory, it was going to work nicely. So we now have these common state actions. We have these standard results chains. We really like actions as the basic unit of learning. Because if we really want to learn how to make stuff better, actions are pretty cool. They're the unit of work. They're what people actually do. They're all the cures that our quote-unquote equivalent of doctors are using to treat different conditions around the world. But if we really want to learn, we also have to have people share failure. So if I'm your funding officer, Jessica, I'm going to pick on you. If I'm your funding officer, and and I come to you and say, hey, Jessica, I'm giving you all your money. How's your organization doing? What's your answer going to be?
Great.
Great, right? John, I'm your program officer. I'm giving you all your money to your project. How's your project going?
Even better.
Even better, right? But where's the learning in that? We all know that the reality is not that. But if I went to one of you and said, hey, you tried that action, did it work? You just might be willing to say, because it's a small enough unit, hey, I had some trouble with that action, it didn't work so well. So we're trying to get things down to that unit where people actually might be able to work and report successes and failures. So all these actions fit into a larger classification a few years back, and I'll show you more about this in a bit, but we created a standard classification of threats and actions. This is a list of all the standard actions in the world, although about version 2.0 this is about to come out, which is a lot different, and that's interesting in its own right. So here's what we've created. So just like biology, the science of biology is all founded on type specimens. So if you go talk to Ed Wilson will show you, an ant with a pin on it. Okay, that's not actually that ant, but it's a good example of it, which is the type specimen for that ant, which is the foundation of the science of biology. You have this file cabinet of these sort of type specimens, of which kind of leads to what biology is happening, right? What we're trying to create, or what we have created, is something called CAML, the Conservation Actions and Measures Library, which is an online file cabinet of standard results chains for different kinds of conservation actions around the world. So if you're going to go start a project and you want to have measures, you don't have to start from scratch. You can go to this library, check it out, pull it out, and start and base your project off what's there. And that's the basis for true cross-project learning. We can start to get information from a few sites and then take that information and come down and affect many sites by having that learning coming and raining down. So that's model C for going to scale. And the fourth model, the last model, is what I call growing the pie. So if we want to have all those sites that you showed you before, someone's got to pay for them all. Where are we going to get the rupiah or the dollars or the euros or whatever it is to pay for all that stuff? Here's the challenge we have in conservation. We are competing with society for many other worthy causes. So let's talk about education of school kids, and let's talk about malaria eradication, and let's talk about conservation. Here's what I believe. If we can't show that the dollars or rupiah or whatever it is that society is giving us are going to be used effectively, our pie is going to shrink relative to those other worthy causes. Now, don't get me wrong. I'm a fan of malaria eradication, or that's education of school kids. I'm a fan of malaria eradication, okay? But it is a competition out there, and we have to document effectiveness if we want to achieve what we want, get the resources, and maybe keep our pie level, or maybe even grow and have our pie take over the world. Wow. So the cool thing about these standards is it's a way of sort of standardizing information. So they're starting to sneak in surprising ways. If you go to the CAML Foundation, which funds work in the Chesapeake Bay and elsewhere, it's a small family foundation. But if you look at their project grant proposal right now, they ask you for your conservation target scope. They ask you for your threats and opportunities, and a whole bunch of other stuff. So they're actually sneaking the open standards in on you as a way of standardizing the information. They're not making you use Miradi or all that software or all that stuff, but they are kind of thinking and doing this kind of way of thinking. In a similar way, Mickey Mouse, Walt Disney's animal program, they're using the open standards, and they actually just released just their Miradi laptop, which I thought was pretty cool, that Mickey has. But their reverse the decline program is actually now mandating the use of the open standards in Miradi in terms of 10-year funding effort. So this stuff is coming, and people are starting to use it. Probably the really big one here for us is USAID, United States Agency for International Development. We're working pretty closely with them now to take their program cycle that they use. They're never going to use that cycle. They have their own language and own way of doing business. But we're trying to infuse it with a lot of these tools. And so, for example, that's the terms that we use in conservation. You can see a lot of things in a results chain. That's the USAID terms. We've had to change the names a bit, but it's really the same underlying principles coming into what's happening with USAID. And it's helping these guys show that the work being done is credible and effective so that they can make the argument to Congress and to the government that they need to keep funding coming. So going back to that fish and wildlife example, remember the scary OMB guy? The funny thing is we never actually got, or we still as of today, haven't gotten that system totally off the ground, but we got huge credit for even just trying. By trying to show performance and showing that we're actually serious about this stuff, the OMB examiner was able to say things are actually moving along in an interesting way. Okay, so that's a little bit about just different examples of what this open standards is and how you apply it. I'd like to talk now a little bit about how we support adaptive management. So we have these open standards, and I said they are a formal standard. It goes through a change control process. They grow and change over time as we get innovation, and they get adapted and folded in. We're up to version 3.0 of the standards. There's lots of guidance that different folks produce on how to do their steps, like threat ranking. And we have tons of workshops. That's on the floor of a hut in Papua New Guinea. That's in Switzerland somewhere. But we're going through these processes of coaching people how to go through this process. This may be of relevance to folks in this room. There are lots of training courses and coaches in how to do the open standards. In fact, you can now go to about 15 universities around the world and take a course in the open standards and graduate knowing how to do this stuff. So all these folks are now learning how to speak open standards language. You guys feeling a little left out? Want to be a part of the party? There's also a network of a whole bunch of coaches and countries around the world where this stuff happens. Actually, our goal is that within 5 years, every major environmental program that has students coming out, just like in the 90s, people started to learn how to do GIS. It was something you learned about when you were in a program like this, that you'll come out of this learning how to speak the open standards. To that end, there is something called the Teaching Adaptive Management Network, which provides a syllabi and examples of how to put courses on for this. Some of the courses, the original Maryland course was completely student-led. Students just said, we wanted to do this and got their faculty to do it. Other places it's been faculty-led. But if anyone's interested, either faculty or students, I'd be happy to put you in touch with these folks and we can figure out how to get a course going here as well. As I said before, another part of the puzzle that we work on are standard terms to describe conservation work. So if that's your problem, if you got a bunch of cows in your watershed, and if one group talks about that as cows, the next cattle, the next livestock, the next grazing, the next ranching, when you put that in a database, you really never know you're all dealing with the same issue. So especially for the diseases and especially for the cures, just like medicine has to name the diseases and then think about how cures work. As I said before, we worked with IUCN. They came up with a whole red list set of threats and actions, a classification. CMP did the same thing, oops. But the cool thing was that when we compared the two efforts, it was actually about 85% overlap. So we were able to create a unified set of classifications, and we actually published that, as I showed you before. Anybody here use TurboTax? We're coming up on tax time. A few of you, okay. So the great thing about TurboTax, the great thing about software is when you have a complex process like doing your taxes, it's nice to have software that gives you a step-by-step kind of guide through the process and then gives you all the forms to fill out. So Miradi, which I mentioned before, is a software program we run that helps people implement the standards. It's kind of modeled on that, where there's an interview that walks you step-by-step through the open standards process, and then there's tools to do things like the threat rankings. So a lot of those diagrams and a lot of the stuff I've been showing you come out of Miradi, which is a software tool to support this work. It's desktop software, works locally, but it gives you, that's just a sticky tarp. That's just a tarp where you can put information, but you can do it electronically, which lets you do it over WebEx or kind of share it or put it with other people. And then moving from projects to programs, if you remember this slide, we've now created really recently something called Miradi Share. It's a cloud-based system where managers can actually set up standard terms. Remember my mountain lion problem with standard terminology? Program managers can now define common ways and templates for their programs. We can use that to create individual files that people work on, so what we're doing in Idaho. But then the real hot data sits in the cloud, and once it's in the cloud in a SQL-compatible database, you can search it, you can query it, you can learn from it and see and share it with other people or create reports from it. So we're entering this world of getting online. It allows cross-project, AKA program reporting. So in this case, we can actually show each colored area as a separate project in TNC's Lake Michigan program, and then we can look at the viability and kind of start to map that out. So where this is heading is it's actually taking open standards, which traditionally was focused on the what question, what should we do, and it's starting to merge into the where question, the realm of mapping and Markson and things like this, of where in the landscape should we work. As things get larger, we see this is now becoming a platform for actually adding spatial analyses to the open standards. So we haven't done this yet, but hopefully in the next year we're going to be adding spatial analyses, and for those of you who have a bent or would be interested, I'd love to sort of think about how to coordinate some of that work. So we think that together, the common standards, relevant training outreach tools, standard nomenclature, software guidance, and databases, all those things that we're working on, not just as one organization, but as a collection of a whole bunch of organizations and agencies, collectively those add up to the ingredients for adaptive management and learning, AKA an applied evidence-based science of conservation. So we hopefully are starting to make some progress in that regard. In my last few minutes here, I'd like to just give you some potential reflections on what it takes to create an applied conservation science. So we good? A couple more minutes and then we can go have refreshments? What? Okay. So, in doing this work and working on adaptive management stuff as I've described it, we get a lot of grief. And in particular, what's interesting, we get a lot of grief from two sides. I get all these practitioners coming at me saying, God darn it, we're so busy. We're in what Peter Senge would call ready, fire, aim mode. We're just do. We don't have time to do any thinking or planning or work or time, stuff like that. You're asking us to do too much by doing these models and these plans. We got to get on with it. On the other hand, I'm afraid some in the academic community, probably not folks in this room, but some in the academic community give us a lot of grief by, oh, your models are too simplistic and you need 10 years worth of study to get anything done and it's not really all that functional. So we are interested in adaptive management. For us, an adaptive manager is in the middle. They want to get stuff done. We want to get stuff done, but we want to be deliberate about it. We want to be smart and we want to learn as we go. So good adaptive management requires good real-world scientists. And I've added a few of these slides in today, actually, because I was watching the presentations, and I think you guys are on the cusp of becoming really good real-world scientists. But I want to sort of talk a little bit about what that takes and what I've learned about this. So I'm going to ask you a warning here. The following are only philosophical musings and are not intended to influence specific student projects. Do not try them on your thesis committee without careful consideration of their attitudes and the consequences, AKA at least don't blame me, okay? So this is your warning. So one of my favorite books, and I brought along a copy, is Zen and the Art of Motorcycle Maintenance. And I don't know if some of you, anyway, how many people in this room have actually read this book? So a few folks, okay? I'm going to read you a passage, just a quick passage. A man conducting a gee-whiz science show with $50,000 worth of Frankenstein equipment is not doing anything scientific if he knows beforehand what the results of his efforts are going to be. A motorcycle mechanic, on the other hand, who honks the horn to see if the battery works, is informally conducting a true scientific experiment. He is testing a hypothesis by putting the question to nature. Okay? That, to me, is always encapsulated what science is, what the power of science is. It's that true scientific experiment to make the world or to fix something or to make the world better. So what he's talking about is you have a research question. Why is my motorcycle not working? You have an underlying model, the sense of what the electrical system is and how the horn is connected to the battery. You have an experimental design, you have monitoring and analysis, and you have iterative adaptation as you go through that process. This is science. We pretend it has all those fancy trappings of PhDs and all that other stuff. No, this is really what science is. And I think Pirsig's right in that regard. So I hope you see that these open standards, okay, this stuff does look a little bit simplistic, but it's honking the horn. Because what we're saying is, this is our theory of change about how this is going to lead to that. That's a research question. We have an underlying model. We have an experimental design. We have monitoring analysis, and we have iterative adaptation. And here's the key. This research could be done in any number of ways. It could be a simple pretest post-test analysis. It could be a randomized replicated controls with 20 years of 50 postdocs working on it. We're not saying what the level of intensity is. We're saying that you have to do the right level of research. Okay, I'm going to share some of my favorite quotes with you. So another quote I like is, in research, it is much better to discover an approximate answer to an exact problem than to discover an exact answer to an approximate problem. And this is, I think, what a lot of you guys are wrestling with, looking at your presentations. It's actually not research, it's problem formulation. How do you take these big interdisciplinary things that you're messing with and try to come up with a tractable problem that you can get your head around and solve? So my wife and I asked our kids the other day, a couple of years or so back, what's an estimated answer to that problem? Not the exact, and so what they both took out pen and paper and started trying to do the multiplication and came up with whatever the exact answer was. And it was the hardest damn thing in the world to get them to say, well, it's probably 500 times 500, which is 25,000, right? But it's really 2,500. But it's really hard to get kids, as it turns out, it's really hard to get adults to estimate and approximate. Everyone wants to be exact. And yet, do we really need those exact answers when approximate ones will do? So I've been thinking a lot. Everyone's high on dashboards lately. And I want to talk a little bit about dashboards, but I want to talk about automobile dashboards. So that's a gas gauge. And if you think about what a gas gauge does, there's an information need or a management problem. I don't want to be stranded on the side of the road. I want to know when I need to go get gas. There's an actual measurement that needle represents. So it's technically the level of liquid in your tank. And I'm kind of have a float there that's measuring the level of liquid in the tank. But that's actually not very interesting. What's actually interesting are the interpretive markings to trigger action. It's the full, the half, and especially the empty that's particularly useful in this case, right? And the empty is so important that they actually create a little light that goes off when you get near empty. And what's really interesting is now that technology's gotten better, they're starting to throw away that gauge and they're giving you that, which is a purer form of the actual information that you want to have. Okay, so people get hung up on metrics and measures, and everyone thinks about the needle, and nobody thinks about the interpretive markings. So I'm obsessing with these interpretive markings. Let's take another gauge, tachometer. So again, in this, if you're driving a manual shift car, the information need is, when do I need to shift gears? So you have, it literally measures the rotation of your the drive shaft and how fast it's doing. And by the way, the car manufacturer has to spend some money putting a little sensor in there and a whole bunch of stuff to actually get that measurement and transmit it to your dashboard. And oh, by the way, that's taking up a bunch of space right in front of your face. That's pretty valuable real estate, right? And then what's the interpretive markings? Well, it's probably when you have to shift gears or if you're going to redline and blow out your engine. But if you're driving an automatic car, what's the action you're going to take based on what your tachometer tells you to do? It's useless. You only have it there because it looks cool, right? So it's cluttering space and taking resources. So that's an example of a bad gauge, a bad measure, but there's no management action coming off of that. So one of the tricks of open standards is something we call viability analysis, and we try to look for key species, a key attribute. So we may care about toads in Idaho, and one of the attributes is the size of the toad population. And one thing, we want to have a handful of things that we can measure to see how they're doing. So percent of the breeding ponds with egg masses. And we can define buckets of what's poor, fair, good, and very good as a way to sort of spread out where are we in any given situation. We're never going to try to count toads, that's crazy, but let's look at occupancy of ponds. We might have another condition that we care about, which is the absence of chytrid disease, of BD. And in this case, maybe the measurement, all we really need is none, few, or many. Because as soon as you have some disease in one of those ponds, you got a management issue. Does it really matter how much? No, I mean, it's none versus few versus many. Or if we care about toad species and connectivity, maybe these vernal pools dry up and you need that pond to be recolonized. So the real interesting measurement is how far is the pond from the next one, and are there any barriers in the way? But we can actually create a hoppability index, right? Can the toad hop there? And if it's hoppable, you're in good shape. And if it's barely hoppable, you might do something. And if it's not hoppable, you better do something about it. That warning light's gone off. So what we're really interested in is if you think about that gas gauge, and this is the analogy, these are the automotive analogies. This viability analysis really meets all those criteria for a good gauge. What is it that you're trying to do? Conductivity is what we care about. Here's the actual measurement, but that's the interpretive rankings that we're going to be looking at. Which kind of leads to my next point, my next favorite quote. Oliver Wendell Holmes Sr. said, "I wouldn't give a fig for the simplicity on this side of complexity." I'd give my right arm for the simplicity on the far side of complexity. We're dealing with really massively complex systems, and one of the big mistakes everyone makes is they make these hugely dynamic models where everything's connected to everything. But what I love about this indicator, you actually needed somebody with a hell of a lot of ecological knowledge to develop this indicator, but they've translated it into into a concept beyond that complexity that a policymaker or a manager can get their heads around. And that's what I love about this, is it's not simple. It's not bad simplicity, it's the simplicity on the far side of complexity. Someone's gone through that valley of craziness and come out the other side with something that actually makes sense. And that leads to the fourth, which is iteratively managing uncertainty. In every workshop I ever lead, I always start with the perfect is the enemy of the good. And those of you who are modelers all know all models are wrong. Some, and it's only a few, are useful. But I get a lot of grief from people like, oh, when you do these box and arrow diagrams, well, you should allow for the thickness of the arrows to change, and you should allow for dynamic modeling of the relationship between these different parameters and Bayesian belief networks and all that kind of stuff. There are situations where you have to do that level of analysis, and there's plenty of software tools out there that support that, and I think it's great to use those in certain places. But I'm telling you, I'm having a hell of a time getting a bunch of conservation practitioners just to lay out that this causes this, and this causes this, and oh, there's a big question there of whether that's actually working. And then that leads to this. This is 80% of the battle. If you can get people to lay this stuff out, the rest is gravy. And so we're really focusing on that 80-20 rule, that return to effort. If we can get a group of people to agree that that's what that system in Idaho looks like, and hey, maybe we even need some more research there to make that work, that's really where we need to be. And you notice, not everything is connected to everything. Could you make an argument that somehow rural housing development is also leading to this or to that? Sure, you could. But if you link everything up, it's more accurate as a model, but it ain't more useful. So these are not reality. We're trying to get the essential simplicity that gets at people what they need to make good decisions. A fifth point I want to talk about is who should be doing science. So I think we'd all agree, and I've seen this in a lot of presentations, our goal is to have resource managers using science to inform decisions. Everyone agree to that? Seems pretty good? And someone, I forget, Sue, someone had actually a bit of a slide on this, but so I apologize. I swear I wasn't plagiarizing this from the presentation earlier today. The traditional paradigm is academic research, which is published in scholarly journals. It's then translated for practitioners. It's then read and understood by practitioners, and then they use it to inform their decisions. We were really interested in kind of the adaptive management model, which is the practitioners themselves doing research, which is communicated to internal and external audiences, is read and understood by practitioners, and then they make decent decisions. So here's my own evolution. 15 years ago, when we started Foundations of Success, we were on a mission. We were on a mission to wrest science away from the academy. We were going to go and just put it out there and get practitioners themselves doing all their science. And here was our hypothesis back 15 years ago. What we were arguing was that let's just assume that academic research is of higher quality and practitioner research is of less quality. And I wasn't even necessarily willing to make that, but I said, okay, for the sake of argument, let's assume that. Our hypothesis was that the amount of sort of information that's retained as you go through those different steps, you might actually end up with more coming from here to there. Okay? So we set out to sort of create. If you ever read Where There Is No Doctor, we set out to create sort of Where There Is No Scientist, this idea of kind of helping people actually do science in the field. I've come a long way in 15 years. And it's made me really appreciate it. It goes back to Pirsig and the motorcycle mechanic and all that stuff. Science is a craft, and you really do learn how to do it. And places like this hone people's ability to learn how to do science and how to do it well. And I do think that the answer is not one or the other. It's actually both. I mean, that we need this interplay between both of them. What I do want, though, is the idea of maybe more the barefoot scientist, that the scientist has to come out of the ivory tower and be there in the field working with these folks and supporting them. And from looking at all your presentations, I think a lot of you are headed in that direction. But keeping that interplay back to the academy, that's why I come here, because that interplay is really important and where things need to be. The sixth point I want to make, and I kind of alluded to this before, is that the burden of proof depends on risk, cost, and the time frame for decision making. So if you go back to behavioral ecology, I started off life as a behavioral ecologist, and if those of you familiar with parental investment theory, there is the R-selected species like an oyster, and there's the K-selected species like a primate. So an oyster has tons and tons of offspring but doesn't invest in them, and the primate has only a couple and they put a lot into each of their kids. It's a lot like that for adaptive management. So let's take two foundations. One of my favorite grants I get every year is from the Maristla Foundation. They give about $330,000 grants out on a one-page application form and a one-page report. They're oysters. They're just chucking money out to people who they think are good, and they're hoping some of it sticks. I love that grant, by the way. That's great, right? The Packard Foundation might, on the other hand, give out a $10 million grant or a $50 million grant, and they're going to do they're going to insist on a lot more measures and a lot more performance of what's going on. So here's the point. You don't want to spend $1 million to measure a $30,000 grant. You're going to invest in adaptive management when the stakes are high, where there's a high cost of error and action, when there's a potential to level learning, and when the cost of measures are low relative to the action. So this is what I was saying before. The open standard, it's not all just quick and dirty science. It's really about the right mix. It's where do you need to go deep and really do pull out the full-fledged, double-blind controlled study? When do you need to do the quick and dirty stuff? You've got to find the right level for the right place. So all this comes together, and I would argue that if we can create a culture of data sharing, so remember back we started this whole discussion about this idea of dumping woody debris and does it work? If we create that culture of data sharing and we share information and we put it into line and we share our failures and our successes and we have common terms and ways of describing stuff, then we're actually creating a massive replicated experiment about what works and what doesn't and what conditions. And it's already starting where people like Andrew Pullen at the Center for Evidence-Based Conservation, they can start to analyze all those different experiences and find out what works and doesn't work. They can do meta-analysis. So in this case, they're actually finding that woody debris in certain conditions does increase the population abundance of salmon. Hooray. But there's a lot of other stuff that we're doing is more like the bloodletting. So we're going to get smarter and more effective at what we do. And that really is what the science of conservation is about. So that was my official presentation. That's how you can find out more. You can download a free trial copy of Miradi or play around on Miradi Share and look at some of that information. I will stop there. We have 5 minutes left, so I'm happy to entertain questions. If you want, though, I also have two more slides that I added this afternoon because I was kind of really inspired by watching all you guys, and I wanted to share a little of my own personal experience. So if you're okay, can I take 2 more minutes and share something with you? So my heart went out to all you guys working on these conservation, different interdisciplinary projects, and I'm really excited to come here and see how much institutional support there is for interdisciplinary research. So back in 1990, I was a grad student, and I set out to do a very interdisciplinary study. And what I ended up doing was looking at this forest garden project. So this was in Borneo, in West Kalimantan. This is a land use system that people there had developed. It includes farms, home gardens, forest gardens, all the way up to natural forest. I got really captivated, but I always wanted to sort of look at it from different perspectives. So I ended up writing a dissertation that had one chapter on the history of the system, one on agroforestry processes, one on soils and nutrient cycling, one on wildlife use, one on economic cash flow, one on non-timber forest product harvest, one on a transmigration issue, and one on climate change. So I was all over the map. But it was also focused, right? Because the traditional paradigm is you learn one academic discipline and you apply it to multiple systems. This is the inverse. It's still focused, and I think that's one piece of advice to a lot of you out there is you still have to focus what you're doing, in this case, trying to describe this particular system. Anyway, this is a little embarrassing, okay? But it's kind of going back, but I was sort of inspired. The last chapter, the 9th chapter, as I wrote about experiences doing interdisciplinary research. So I actually cribbed what I wrote at the time were the 10 commandments for the interdisciplinary researcher. I haven't thought about these in 18 years or 20 years, but talking about what's going on here, I thought I'd share a couple of these with you guys, okay? And you can see, I don't know what I was smoking back then, but all right, there you go. So the first commandment is that the whole is greater than the sum of its parts. And I wrote here, if you can't accept this one on faith, better to be writing encyclopedic monographs on the sexual behaviors of subspecies of liverworts. At least you might get tenure. Okay. The second is thou shalt not worship graven idols of bad science, but thou shalt conduct quick and dirty science. I think that's what I meant by adaptive management at the time. But even at the time, bad science is that what researcher has no true hypotheses, is more concerned with procedure rather than result, and or collects sloppy data. By contrast, quick and dirty science seeks to answer urgent and meaningful questions with a minimum of effort and time. So it's kind of back to some of the Robert Pirsig stuff. Third one, thy name will be taken in vain by the specialists. Okay? It is hard enough to stay on the cutting edge of one discipline. To do so for many disciplines is impossible. Accordingly, every specialist will take your work apart for not being up to the standards of their discipline. So you got to get over it and develop a thick skin and chant Rule 1 as your mantra. Chapter 4, or point 4. Remember that time is holy, thou shalt not rest while in the field. So as I wrote when I was a letter in the field, at the most basic level, this project is an optimal time allocation study with myself as the sole subject. If you're trying to work across 8 different things, you got to figure where every data and every piece of information is going to go over time. Honor those who combine, conquer, and publish. So you need to, basically this one is basically saying that every datum that you collect, you have to know where it goes. You have to be efficient. You have to think about efficiencies and ways of making stuff work. Thou shalt not kill thyself over a failure. So you're going to have to try things and you're going to fail miserably and you're just going to have to get up and get over it. Thou shalt commit intellectual adultery, which leads to cross-disciplinary arbitrage. So one of the huge advantages of dancing on the fence is you can steal all these things from the economics world, bring them over to the ecology world, and seem really smart. And people's like, where did you learn all that stuff? Well, you know. So you can really be smart about how that works. 8 was thou shalt not steal, thou shalt collaborate, which is, I think, interesting noticing here in some of the talks that you all gave. There were multiple authored, which is not typical of a graduate student presentation. It's supposed to be your work. But when you're doing interdisciplinary work, it has to be multiple people. Guess what, though? That's really good training for the rest of the world and then for real-world work. And so I think it's a really important part of this overall process. All right, this one's a little dated. Thou shalt not bear witness that results from committing myriad facts to memory. You should just find out where to find them. That's 1990, folks. That was pre-internet. So back in the day, it was really overwhelming to figure out where to get the information. These days, not so much. That one didn't last so long. And then the last one was, thou shalt not covet thy colleagues' networks and funding. Interdisciplinary research can be a lonely pursuit in that you are always on the outside and never a member of any one department, discipline, or funding pipeline. I feel that I was fortunate to be at school and with advisors and friends who are not only tolerant, but actually promote interdisciplinary work. And I think that's what gives me most hope about seeing what you guys have, is that you really have a program and a network of people who can create that for you. And I think that really is the foundation. So I'll let it go there, but see if there are any questions.